Number 34. The diagram shows the level X. X level is somewhere here, and Y, which is labeled here, in a liquid manometer. Here is a liquid manometer. With the gas tap, here is a gas tap. What is the pressure of the gas supply? Okay, suppose the tap is open, the gas will move. Gas will push liquid from here to here, and this liquid will rise from here to here. Okay, before the gas was allowed, the this liquid was here, and it was still here. Okay, at that time the liquid was still till now, but before that, because it's open end, from here you can see it's an open end, as well as here the gas is the liquid is experiencing atmospheric pressure here. So when it is when there is an atmospheric pressure and gas is also supplied from here. Okay, gas is here. Okay, so when gas will move from here to here, then atmospheric pressure is here. Atmospheric pressure is here. So this one plus this one, this total is between these two is 18. So in centimeter it is 18 plus atmospheric pressure. So total pressure is, gas pressure is normally atmospheric pressure plus liquid pressure. Sometimes liquid pressure is measured in is related with height, and there is also a formula, we are familiar with it. So atmospheric pressure is equal to, and liquid pressure is rho GH, and this is gas pressure. Okay, rho GH, suppose atmospheric pressure, rho GH is like, let's assume that 9 plus 9 is, in terms of height, it is 18 plus some atmospheric pressure. Okay, now let's see the options. 18 centimeter of liquid below atmospheric pressure, 18 centimeter plus some atmospheric pressure. So this option is wrong, because it means the pressure is like below atmospheric pressure, means whatever the atmospheric pressure is minus this 18, like the liquid pressure is 18 and there is a plus sign, not the minus sign, so that it would be 18 less than the atmospheric pressure. So that's why this term is incorrect. 9 centimeter of liquid below atmospheric pressure, no, like there is no sense of 9. So it is actually like about 18, not 9. Like 9 is 9 plus this 9 is 18. So there is no sense of 18. 9, sorry. It's all about 9, 18. 18 centimeter of the liquid above atmospheric pressure. That's correct. Above means, here is above. Above means whatever the atmospheric pressure is, now add 18 in atmospheric pressure, or 18 is the pressure of the liquid, and now add atmospheric pressure in it. So that's why this option is correct. Okay. Next is 5 blocks have the same mass, like suppose 1 kg, 1 kg, 1 kg, 1 kg. But different base areas, this area, this. they all rest on horizontal table. Okay, so suppose their mass is 2 kg. Let's assume that it is 2 kg. Now the question may be related. Okay, now weight is mg, so 2 times 10 is 20. So weight is 20. Okay. Now, the graph is plotted to show the relationship between pressure exerted on table and the base area. Okay. So on y-axis we have pressure and on x-axis we have area. So the graph is between pressure. Okay. So here is pressure on y-axis and area, base area. Area is on x-axis. So it's a relationship between pressure and base area. Which graph shows the relationship? Okay. Now you can see the formula of pressure is weight per unit area or force per unit area. So now you can see in question we are given one information. 5 blocks have the same mass. When all have same mass, it means all of them will have same weight. So weight is going to be a constant quantity in this question. So you can replace this weight, you can consider this weight as a constant quantity. So I can write it as 1 over area, and it would be a constant. And when there is a constant, you can replace it as so you can see pressure and area are inversely proportional to each other. It means if you increase the area, pressure will decrease. If you increase the pressure, area decreases. So pressure and area are inversely proportional. So let's see one by one. Okay, this graph says when area is 0, pressure is 0. When there is nothing, how can we say there would be pressure? So this graph says, okay, if you increase, like you can see, pressure is increased, area is increasing, pressure is increasing. Area is increasing, pressure is increasing. Area is increased, pressure is also increased. Now come back. You just go down in a graph, you will see pressure is here, area is here. If you go here, pressure is here, area is here. If you go back, pressure is here, area is here. It means this graph represents that the pressure and area are directly proportional, which is incorrect statement. In this graph, both pressure and area are directly proportional. Okay, look at this. It states that pressure at start, pressure increases, then pressure like with the increase in area, pressure is not increasing as like it was increased in previous case, like further. So it means pressure and area have no relationship. It's a random graph, because you can see sometimes it is steeply increasing, then less steep, then normally, and then it is going in a random way. So this graph is also incorrect, because there is no proper relationship between pressure and area. Now look at this graph. It says pressure decreases, area increases. Pressure decreases, area increases. To some extent it is correct, but actually it's a direct inverse proportionality. But here the proportionality breaks. Here is a breakdown, here is a breakdown, and like you can see, there is no proper there is no proportionality. There are breaks. There is a break, there is a break, there is a break, and after break there is a change in it. So that's why this option is incorrect. Okay, now let's see the fourth one. In okay, it looks fine, because it starts from non-zero area and non-zero pressure. We know that if it starts from here, it means zero area. If it starts from here, it means zero pressure. So it means there is pressure and there is area as well. Okay, now it states if you increase area, like I am going to increase area, you will see the pressure is decreased. I'm going here, you can see pressure is further decreased. If I'll go here, you can see pressure is further decreased. If I'll go here, you will see pressure further decrease. It means this is exactly equal, is following the inverse proportionality. So that's why this is the correct option. The base of a statue rests on level ground. Okay, here is a base. It is made from stone and is 2 meter long. Okay, it is made from stone and 2 meter long is this one. 2.5 meter high, this one, and 0 meter, 0.8 meter wide. Okay, it has a weight of 96,000. Okay, what is the pressure that the base exert on the ground? Okay, we know that area is length into width. Length is 2 meters and width is 0.80. So it would be 1.60. Okay. Now weight is W equals 96,000. It is already given. So now you can calculate pressure is weight per unit area. Weight is 96,000 and area is 1.6. So 1.60. So now you can use calculator. It would be 60,000, and 60,000 can be written as 60 kilo. Okay, Pascal is PA. So this is how you will calculate the pressure. Okay. An engineer design a dam wall for a reservoir like this. Dam wall is here, and here is a reservoir. Which factor determines the pressure at X? Okay, here is the point. X. Now it states which thing is going to determine the pressure. Pressure is weight and area. The depth of the water in the reservoir, the surface area of the reservoir, the length of the reservoir, the thickness of the dam wall. Like you can see, we know that pressure is weight over area. We also know that pressure is rho gh. Okay. If the point is here, its depth is this one. If the point would be somewhere here, its depth will, like suppose x is somewhere here, somewhere here. So we have three different points. Okay, this is the point. Suppose x is somewhere here, x is somewhere here, and x is somewhere here. We have three different points. Now you can see when the particle will be here, it is experiencing more amount of water on it. When it will be here, less amount of water. Here, less amount of water would be on it. So when amount of water is decreased, its weight will decrease, pressure will decrease. So it means the amount of water is high here, due to which the weight would be high, would be large, and that will, it means pressure would be large. We don't know the pressure, but we have given the information. Okay, it now you can see the large depth, large weight, small depth, small weight. Similarly, so in terms of weight, we can see if the depth is large, if depth is large, weight would be large. Weight would be large means pressure would be large. So we can use second formula as well. This is related with depth. So here is the depth. If depth is large, pressure will be large. If depth is large, weight will be large. Weight large means pressure is large. So, okay, let's see the options. The thickness of the dam wall has no concern with the pressure. The length of reservoir is something here. It has no connection with the pressure. Surface area of the reservoir, the surface area has no concern because we consider the surface area which is just considered, which is just connected with x. So we are left with only one thing, which is depth of the water in the reservoir, which is here as well. Okay. Next is a builder leaves two identical heavy stones tiles resting on soft earth. Here is one is vertical and other is horizontal. This is vertical, this one is horizontal. After a few hours, the vertical tiles has started to sink into the soft earth. Okay, you can say marshy land, but the horizontal one hasn't. Which row correctly compares force and the pressure of the tile exerted on? Okay, you can see, okay, like both tiles are same, like whether it is horizontal or vertical, it means both will have same weight. So when their weights are same, it means their force is same. Okay. Now let's consider them independently. Suppose its weight is 100, its weight is also 100. So let's calculate the pressure in both cases. Okay. In this case, look at the surface area which is in contact with Earth. It's a very small surface area in vertical case. Suppose it is only 2. So 100 and area is 2. It would be 50. And what about this one? Weight is 100 and area, you can see comparatively area is very large. Let's consider it is 20. So pressure is 5. So in this case we have pressure 5 and in this case we have pressure 50. So let's look at the options. Which rules correctly compares the forces and pressure that the tile exert on earth? Forces. Both, like you can see, like the weight of the tile, both that of both tiles is same. So both of them will have same force. So we are going to consider the same option. Same force, same force. And this option is incorrect. Okay. Now pressure. Now you can see the red one has a pressure of 50 and the blue one has 5. So both have different pressures. So different is here, different is here. So this is incorrect, this is incorrect. So overall we have our correct option is this one. Okay. Number 39. A water manometer is connected. Okay, here is a water manometer to gas supply. One end of the manometer is open to atmosphere. Yes, this is open to atmosphere. Atmospheric pressure is acting on it. Similarly, here as well. Okay. Which statement about the pressure of the gas supply is true? Okay, we have just solved the kind of similar kind of problem in which pressure is gas pressure is sum of G for gas, A for atmospheric pressure, and liquid pressure. So now what is this? Which statement about the pressure of gas? Gas pressure is true. So it is equal to this, the sum of these two. The pressure is H centimeter of water. So it is H. No, it is H plus atmospheric. So this option is incorrect. Okay. The pressure is H centimeter of water below atmospheric pressure. It is greater. It is atmospheric is this one. And when you add something in atmospheric pressure, that would be equal to. Next is the pressure is same as atmospheric pressure. No, it is greater than atmospheric pressure. The pressure is H centimeter above atmospheric pressure. That's correct option. Okay. Okay, next number 40. A long tube full of mercury is inverted in a small dish of mercury. Okay, it is inverted. The mercury level in tube falls. Mercury level in tube falls, leaving a vacuum at the top. Yeah, here is a vacuum at the top. When the atmospheric pressure falls, which length decreases? So the science behind it is, okay, atmospheric pressure acts here, and when it acts here in open air place, then due it push this liquid in downward direction, and here is an open position from where this mercury moves in upward direction. From here the liquid starts moving in upward direction. Okay, now this, okay, I'm going to repeat it. Atmospheric pressure here acts here, and the liquid is pushed, and here is an open end, so liquid moves in from here in upward direction. If you increase atmospheric pressure here, then this liquid moves up, 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 and so on. If you decrease this one, then this liquid is pushed with less force, like pressure would be small, then the small amount of liquid will go here, and it will not reach till here, it will reach till here. So suppose it will reach here. So when it will reach here, then this height, like this height decreases. Q is a height which decreases, and R and S. Okay, this liquid moves in upward direction, so this increases. Okay. When the atmospheric pressure falls, it means less pressure is acting here. So liquid would be this out the liquid which is outside here in pan, a dish, it will move little up. When it will move little up, this height decreases. Okay, PQ height decreases, PQ height, PS height, P to S, Q to R, R to S. Okay, actually Q decreases, then QR would decrease, because Q is here, and sorry, R is here and Q is here. When atmospheric pressure reduces, this liquid moves in downward direction like here. And now you can see previously the QR height is this one. And after some time, if atmospheric pressure falls, it would come here. So you can see QR height decreases. So our option is this one. We have this option.